Okay, so today we're back to factoring. So this time we are essentially looking to do the opposite of expanding. So the last lesson was FOIL, and so when you FOIL, so expand and simplify, you do first, outside, inside, and last. Okay, and then simplify, collect the like terms in the middle. First, outside, inside, and last. And first, outside, inside, and last. Okay, so the question here says, what do you notice about the B and C values? So we did talk about this in the FOIL lesson, 5.2. Why do we do first, outside, inside, last? Does it really matter? And remember, this is going to be important later. So we called this standard form. Okay, so standard form, you have the x squared term goes first and the b squared term goes second and the c squared term goes last. So when we factor, if you look at the b and c values, so the b value are the number terms, I guess it's bad English. Where the numbers are added. So this term here, this B, we have 2 and 3 in the brackets in the first example, that adds to 5. 4 and 5 in the second brackets adds to 9, and 7 and 1 in the third brackets adds to 8. Okay, and then the C value is where the numbers are multiplied. So 2 times 3 is 6, 4 times 5 is 20, and 7 times 1 is 7. So we are going to use these two facts when we factor what's called a trinomial. So trinomial means you have 3 terms. So again, it's going to be in standard form, x squared, x, and then a number. And so we're going to take the trinomial that looks like this and write it in a form that looks like that. So actually, you've done both. After today, you will have FOILed, you'll have expanded that expression, and you'll also have factored it. So you can actually use FOIL as a way to check your answer, which is nice. Okay, so if we expand and simplify, if you have a like a random m and n number here, so then you can write this like the x squared term, and then n plus m will be added, and you've got mn multiply. So that's going to be important. We're going to talk about numbers that add to the middle term and multiply to the c term. And that's what it says here, adding and then multiplying. Okay, so when you're first learning to do this, if you want to write a plus and a multiply over top to help yourself remember, you can. So we're going to write 2 binomials that would have been multiplied together to result in this expression. Okay, and then like I said, you can check by FOIL. So if you'll notice in this, in the factoring unit on D2L, there is a file that says multiplication tables. So if you are not good at this, if you hated multiplication tables and you were never good at it, then maybe you might find that file to be useful. Okay, so you can certainly do this using your calculator as well. What you should always do first is consider the multiply and then check if they add, okay? So you can make yourself a T-chart here. So we're multiplying to the C term, which is 18, and adding to the B term, which is 11. And if you're not good at this, start at the beginning. What's always the beginning? And we're only going to do whole number integers, okay? So no 0.5 or anything like that. So we have 1 and 18. So then you check. 1 plus 18 is 19. That doesn't work. 2 and 9. 2 and 9 multiply to 18, add to 11. I'm just going to keep going. Okay, so let's say it was 3 and 6. They are also multiples of 18, but they add to 9. Okay, so then here, this is the row that works. Okay, so we have found two numbers that multiply to 18 and add to 11. What are those two numbers? 2 and 9. So if you choose to do sort of the systematic way of doing it, then when you go and write your two brackets, it actually really doesn't matter, because when you do the multiplying order, it doesn't matter which order you multiply them in. But most people then will put the smaller number in the first one and the larger number in the second one. But you don't have to. I could have written x plus 9 times x plus 2, and it's the same thing. So when you're done, you can check by FOIL, which is nice, okay? So now I'm going to take this and make sure that I get the question back. So first, x squared outer, or outside, inside, and last simplifies to 11x plus 18, okay, which is the question. So this is the simplest case because they are all positive. So let's do one more example where we have numbers that are all positive, and then we'll do some trickier ones. Okay, so now we're going to do the same thing. Multiply to give us 12. Multiply to give us 12 and add to give us 8. So multiply to the last number and add to give us the middle number. Okay, so again, if you're not sure, if you don't know your multiplication tables well, then make this T-chart and start at the beginning. 1 times 12 adds to 13. That doesn't work. 2 times 6 adds to 8. That's a terrible 8, sorry. Okay, so then there we go. There we are at the number that we need. Okay, so when you do this, then yes, there's 3 and 4 as well to get to 7, but you don't have to, once you get the answer you want, I don't expect you to keep going. You can just stop, okay? So then now we're going to do 2 and 6. Again, I'm going to write x plus 2 first. And the only reason why is because usually people have in their first subcolumn here the lower number. Okay. And then again, I'm going to check. So first, outer, inner, last, and then I'm going to simplify, and excellent. Okay, so far we have only had to consider positive numbers, but really technically you could do, I'm just going to add it into our little chart here in a different color. Technically, -1 and -12 also multiply to positive 12. But not to positive 8. -2 and -6 would add to -8. Okay, so if you noticed here in our T chart, we have written the sign. Okay, so that's going to matter that it's, oh, I guess that's not the sign. It is positive or negative. -3 times -4 would give you +12, but -7. Okay, so that does not work. So the next slide, we're going to have some examples where it is, oh wait, are we going to do one more? Okay, yeah, let's do a trickier one. And then we'll look at some patterns if you're the kind of person who likes patterns at the end, okay? So factor and check again, which is great. And okay, so this time now we have a negative number when we are adding, okay? So still make your little chart, and I want the numbers to multiply to 9 and add this time to -10, okay? So that negative is important. You could have just written -10 on that side. When you add a negative, it can mean subtracting. So negatives really start to make things a little bit hairy, but that's okay. We're going to go through, all right? So we have 9 here. So multiply to 9. Okay, so 1 and 9 multiplies to +9, but adds to +10. 9 is not an even number, so it's not going to be 2. I'm going to skip that. Then I'm going to go to 3. 3 times 3 is 9 and adds to 6. So none of those are -10. Now, again, once you start to get good at this, when you write down 1 and 9 in the first row and you recognize, oh, if I made those both negative, I would get a +9 and it would add to -10. You don't have to show the 3, 3, okay? I'm just doing that because I want to show you like a full example, okay? So -1 times -9 is going to give us -10 when you add them. I don't need to try +1 and -9 or -1 and +9, because when you multiply a negative and a positive, then you're not going to end up with this positive number here, okay? So try, again, it's you know, those things that your teachers always said, oh, make sure you remember this, make sure you remember this. And so remembering the tricks when you multiply integers are important. And it's only going to be, for now, it's only going to be even numbers, or like whole numbers. We're going to look at a case later where you actually have to use a formula to solve a quadratic equation because it's just too tricky. Okay, so that's like 5.8, a much later lesson. All right, so don't do all this work and then leave your answer. This is called factored form. Not what I just wrote there. So don't forget to leave your answer as factored form. Writing the T-chart is not enough. And again, what we're going to do later is we are going to solve these equations, and so then what the x values could be is going to be important. Okay, so this is called factored form. So now you want to do the check. If this was a real quiz or test, then if it said factor and check, then you would get marks for the check. First, outer, inner, and last. Okay, and we got our question back, so we are good. Okay, so now let's look at the patterns. So we're going to do one of each kind, basically. So there are 4 possibilities. Either they're both positive. So if you want to get out your highlighters, so we have positive, positive. We have negative, 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 positive, or positive, negative. It doesn't matter. These two are similar, but okay. If you're not a pattern person, then you can just keep making your T-charts, and that'll work every time. Okay. So this one, remembering B and C. So adds to 18, sorry, multiplies to 18, adds to positive 9. So 1 and 18 makes 19. 2 and 9 make 11. 3 and 6 make 9. There we go. We got two numbers. So I'm going to put the 3 first, but it doesn't matter. When the question has all positives, then your answer will have all positives as well. It's when the question has a negative, like this one, and this one, and this one. That means that at least one of your factors has to be negative. And this can be tricky, especially, like I said, if you do not love multiplication tables and all that kind of stuff, then trying to figure out these numbers can take a while. So I would get out a calculator. Again, it does not need to be fancy, and don't guess, okay? Just go through each one. And what you'll find is the more you do this systematic T-chart thing, you'll be like, oh, I remember what 2 and 9 are. So even if you didn't like it before, you guys did tons of integer work in grade 9, then it will start to come to you. Okay, so then I guess I can make my teacher a little bigger up here. So now again, we got C, B, so we're multiplying to 20 and adding to negative 9 this time. Okay, so 1 and 20 is 21, 2 and 10 is 12, 3 doesn't work. 4 and 5 is going to give us positive 9. So then how do we get negative 9? So now when you're doing the homework, I'm not going to go all the way back up to 1 and 20 and make those numbers negative. That's a waste of time. Once you do this, then if you do negative 4 and negative 5, because they're going to give you a positive 20, then that's going to give you negative 9. Okay, so there are eventually shortcuts to this, but it is going to be a process. Okay, so do as much of the homework as you can, as much practice as you can, because you're gonna want that. Okay, so again, we have C, we have B. This time now, we're multiplying to negative 28 and adding to negative 3. So both of those numbers are negative. So now we have 1 and 28. So it's up to you. So 1 and 28 is going to give us 29. And when you add, there's no way for that to give us negative 3. So if you want to go through each one separately, or you can sort of automatically think in your head, okay, well, that I have to, one of the numbers has to be negative. I'm just going to make one of them negative and try it out. So it's really up to you, but I'll just keep going. 3 doesn't work. 7 and 4 and 28. So now you can even make this little chart and then think, okay, so if it's negative 3 that is being added to, that means the bigger number has to be negative. So that's what this is talking about, like m greater than n. So then in this case, they're saying that m is the bigger number, so m has the negative sign. So if you do 1 plus negative 28, then you would get negative 27. If you did negative 1 plus 28, you would get positive 27. So that's where, again, a calculator can come in handy. If you tend to make tiny little math errors, there is no reason, even if we were in class, you would get a calculator every single time. In fact, even the multiplication table I would have given you. So if you like that as a tool to help you do this, go print it off and or keep it on your screen, save it in your iPhone, whatever, or your whatever phone you have, and have it with you. And that is perfectly reasonable. Okay. So now 2 and 14, no matter how I add them, whether the 2 is negative or the 14 is negative, I'm never going to get 3. However, 4 and 7, if I make the if I made the 4 negative, so negative 4 plus 7, I would get positive 3, which means then I can do, actually, write it down. Who cares? We got all the time in the world. Okay, 4 and negative 7 now is going to give me negative 3. Okay, so then you want to make sure it does not matter. You do not need to write the negative sign first, but you do have to make sure that the correct number is with the correct sign. So the best way to do that is to just check. Okay, so why not? So we have x squared, outside is 7x, inside is 4x, and then 4 times negative 7 is negative 28. So now you can check negative 7 plus positive 4 is negative 3x, and we got the correct signs, so our answer is right. So having the correct signs, it does matter. And again, eventually we're going to get to where we're going to solve these, or we're going to talk about what x is and what it means, and including in science, physics, chemistry, everything. So the two x value possibilities here in our two little binomials when you have factored form are going to have important meanings later. Okay, so now again in D, we have a negative sign as well. Okay, so, but this time when we are adding, this time when we are adding, it's going to be positive 2 and multiply to negative 15. So again, decide for yourself. 15 doesn't have that many factors anyways. So 1 and 15 gives us 16. And then the only other factor is 3 and 5 gives us 8. So again, hopefully, you can see that if you do 3 and 5, there is a way to get 2 when you add them together. So try both. Negative 3 and positive 5 gives you positive 2. If you did 3 and negative 5, you would get negative 2. So which one do we want? We want this one. Okay, so you're just looking for the correct signs. And again, what's the best way to make sure you're right? You will be able to check these, like you can FOIL this every single time. So first, x squared plus 5x is outer, inner is negative 3x, and then negative 15. So x squared. So positive 5 plus negative 3 gives you positive 2x, which is good. That's the sign we want. And then, of course, in a positive and negative multiply, make negative 15. Okay, so yes, this is not a skill that you have done before. Please make sure you try and practice as many of these homework questions as you can.